puede ser.
Bienvenidos un año más a la tercera edición de esta Feria de Ciencias en Lengua Extranjera en Aragón. Un año más hemos tenido colegios bilingües de las 3 provincias de Aragón. Como ya sabéis, esta feria nació hace 3 años con el objetivo de acercar la ciencia a los niños y al público en general. Y sobre todo con la idea de promover nuevas metodologías basadas en la experimentación, despertar curiosidad, despertar los procesos cognitivos creativos, como podemos ver por aquí, y al mismo tiempo desarrollar la competencia en una lengua extranjera. Como podéis ver, la gran familia de esta Feria de Ciencias en Lengua Extranjera va creciendo cada año. Además, esta feria intenta promover proyectos de centro, intenta contagiar cada vez más y sobre todo crear un contexto donde se potencie un cambio metodológico necesario en nuestras aulas, fortaleciendo al mismo tiempo los vínculos entre escuela y sociedad. Y solo tenemos que mirar alrededor quienes estamos hoy aquí: alumnos, profesores de todos los ámbitos educativos, universidad, instituciones, administración, autoridades, todos con un objetivo común. Y es que nuestra presencia hoy aquí evidencia un año más que algo está cambiando en los colegios bilingües de Aragón. Gracias a todos por hacer este proyecto posible. Y ahora paso la palabra al decano de la Facultad de Educación, don Enrique García Pascual, anfitrión de la feria. Muchas gracias por abrirnos las puertas de la facultad. Y a continuación nos dará la bienvenida el director general de Innovación, Equidad y Participación del Departamento de Educación, don Jesús Garcés.
Es que aquí cuando en este salón, todavía está sin acordar, está así con una serie de esta provisionalidad, pero que además por otra parte nos permite que tengáis así, digamos, que podamos emplearlo para otro tipo de actividades. Pues daros, digamos, como decía, la bienvenida aquí a este centro, que es esa casa del magisterio, porque realmente nos llena de vida y porque de alguna forma nos invita a trabajar. Por cierto, me olvidaba por el medio, creo que los estudiantes de la Facultad de Educación están colaborando y bueno, pues también veo por aquí que hay profesores de la casa, que sea muy productiva. Yo no me voy a entretener más. Por supuesto que también bienvenida especial a quienes han hecho el esfuerzo esta mañana de venir desde más allá de Zaragoza.
Permitirme que me dirija primero a los chicos y las chicas, porque desde luego es una maravilla, lo decía antes con las directoras provinciales, el planteamiento de ver tantos chicos y chicas de quinto y sexto de primaria es estar tranquilos en las exposiciones, escuchar bien lo que os pregunten, y es un éxito estar ya aquí, los 15 centros. Lo habéis hecho un esfuerzo muy grande en las aulas, estáis haciendo un esfuerzo realmente para cambiar la forma de enseñar, nos estáis ayudando a los maestros y a la administración a introducirnos en nuevas metodologías y en nuevas experiencias. Yo creo que estas experiencias son magníficas, nos están ayudando mucho. Tenemos que agradecer también, como siempre, a Enrique, que nos preste a la casa, a los estudiantes de bata blanca, futuros maestros, compañeros. Dentro de pocos años va a haber suficientes plazas, haremos buenas ofertas y también os quería decir a los padres y las madres que muchas veces los maestros intentamos explicaros y que entendáis lo que estamos haciendo con los alumnos. Eso es una clave fundamental. No se puede cambiar metodologías, no se puede innovar si no explicamos lo que tenemos que hacer. Y los padres y las madres tienen que ser colaboradoras, elementos fundamentales, ¿de acuerdo? Por lo tanto, acabo. Ánimo, tranquilidad y a la ciencia.
A seguir con los agradecimientos. Muchas gracias al grupo de investigación Beagle del Departamento de Didáctica de las Ciencias Experimentales de la Facultad de Educación por colaborar con nosotros. También al Instituto de Nanociencia de Aragón por esa magnífica exposición que nos ha puesto en el hall y que podremos visitar en los descansos. Al programa Ciencia Viva del Departamento de Educación, al Planetario de Huesca, a las editoriales Baimí, Santillana y Netedu, que se incorpora este año a la feria, a los asesores para la mejora de las lenguas extranjeras en Aragón, Steve y Moisés, gracias, y al programa de Ciencia en Acción y a su directora Rosa María Ros, muchas gracias por uniros a nosotros. Y sobre todo gracias a los pequeños grandes científicos que sois los protagonistas de este día. Espero que ya se os hayan pasado los nervios. Muchas gracias por esa ilusión que nos contagiáis cada día a los profesores. Y un especial agradecimiento casi personal a los profesores, que sois los verdaderos motores del cambio, que vuestro trabajo es evidente hoy aquí y sobre todo por vuestro cariño en participar en estos proyectos. Muchas gracias a todos. Y bueno, vamos a lo que hemos venido, que es la Feria de Ciencias. Voy a presentar al jurado, que este año nos ocupa toda esta primera fila. Tenemos a Ferrar Bueno, profesor asociado del Departamento de Didáctica de las Ciencias Experimentales, y Esperanza Díez, jefa de estudios del Colegio Público Río Ebro. Serán los encargados de la modalidad de lengua francesa y seleccionarán un primer premio en francés y un segundo premio, ¿sí? Después tenemos en la modalidad de lengua inglesa a el doctor Enrique Lafuente Millán, profesor titular del Departamento de Filología Inglesa y Alemana en la Facultad de Educación de Zaragoza, y Luis Van Laar, profesora del proyecto bilingüe Make British Council del Colegio Público Valdespartero. Y además tenemos a un jurado de Ciencia en Acción. Es el equipo formado por la directora Rosa María Ros, catedrática de la Universidad Politécnica de Barcelona, que viene desde Barcelona. Muchas gracias por el viaje y por el interés en querer formar parte de Science Fair Aragón. Además tenemos a Marcos Aurey, presidente de la Sociedad Geológica de España, catedrático de estratigrafía en la Facultad de Ciencias de Zaragoza. Gracias. Y tenemos también a Ederlinda Viñuales, doctora en matemáticas, y ha trabajado con Ciencia en Acción en Europa, sobre todo en Alemania. Muchas gracias. Acción seleccionará un proyecto de los que hay hoy aquí, no necesariamente el ganador de la modalidad de inglés o la modalidad de francés, sino un proyecto que se ajuste al perfil que ellos buscan, y tendrán un pase directo a la fase nacional de Ciencia en Acción, que este año se celebra en octubre en Algeciras. Y además tenemos un stand de Ciencia en Acción que está afuera. Vamos a intentar que pase aquí dentro, pero ahora os invitaremos con folletos informativos sobre este programa, en qué consiste. Van por la 17ª edición de su Feria de Ciencias, con lo cual 18ª, vale. Muchos años, mucha más experiencia que nosotros, sin duda tenemos, compartimos objetivos comunes. Y independientemente del proyecto que ellos seleccionen para Algeciras, el resto de proyectos se pueden presentar perfectamente a su programa y después su directora nos explicará más a fondo en qué consiste. Bueno, vamos a empezar ya. Los que estuvieron el año pasado ya conocen un poco la dinámica, lo recuerdo brevemente. Vamos a comenzar por orden de disposición de los displays.
Muchas gracias a la Delegación General de Aragón por su invitación. Yo he venido de Barcelona lleno de curiosidad educativa por este programa, de curiosidad científica también. y especialmente para el grupo de francés. En general, considero que es un doble reto exponer algo así, un tema científico, y en un idioma extranjero. Entonces, quería con humildad agradecer la dirección por la colaboración y señalar mi gran interés. Gracias.
Remainder of the school, and they talk about their holiday. Hi Robert.
Hi Ada, did you have a good holidays?
Yes, I went to London to visit my family.
Sounds good. What did you see?
I saw the Big Ben, the Buckingham Palace, and Hyde Park. What about you?
I went camping and I made many new friends. It was great.
Hi guys, let me here. We are talking about our holidays. Where did you go? I went on a cruise around the Mediterranean, and the tour guide asked a very interesting question. Have you ever thought about how boats float? What's at home? I decided to do some research, and I found fascinating conclusions. Would you like to know about it? Yes, it sounds very interesting.
Okay, let's go to the lab then. Would you like to know how the boats float? Yes.
Good morning, my name is Sarah, and these are my classmates Roberto, Laura, and Beba. We come from the Ángel Artajes in Montego. We are explaining our experiment, why do boats float and some are in sea? We also have observed that boats float in water while some are in sea. This is the question we are trying to solve with this experiment. Why do boats float and some are in sea? We have been discussing it, and our hypotheses are: number one, we think that boats can float depending on the size, shape, and material they are made of. Number two, we believe that submarines can sink because of a motor that makes water go inside them. We have designed two experiments in order to test our hypothesis. Now Roberto is explaining our experiment about boats.
To check that objects float depending on the size, shape, and material they're made of, we put some objects in the water and we observe what happens with them. We take a wooden stick, we put it in the water and we observe that it floats. We take a paper clip, we put it in the water and we observe that it sinks. We take a cloth bag, we put it in the water and we observe that it floats. We take a sponge, we put it in the water and we observe that it floats. We take a nail, we put it in the water and we observe that it sinks. We take a ball of plasticine, we put it in the water and we observe that it sinks. Finally, we take another piece of plasticine, but this time we make a bow shape with it. We take a coin and we put it as passengers. We put the boat in the water, we put the boat and the coin. We see that it floats. Now Laura is going to explain why all of this happens.
With this experiment, we have tried that our hypothesis was right. Both float depending on the size, shape, and material they are made of. But to understand deeply our experiment, we have made up some research. We have learned that all this happens because these parameters affect the force that take place in floating or sinking processes. One is the weight, and the other one is the action. Weight is the measure of a force of gravity on an object. It's a force that makes the object sink. The upthrust or Archimedes principle says that when a body is partly or totally immersed in a fluid, there is an upthrust force that is equal to the weight of fluid displacing. So it's a force that makes the object float. Therefore, to know if an object is going to float or sink, we need to compare both forces. If the weight of the water displaced upthrust is less than the weight of the object will sink. And if the weight of the water displaced upthrust is higher than the weight of the object will float. Conclusion. In the case of boats, the materials are the same in the boat and in the boat sail. But the boat shape has a different shape, and it displays a big amount of water. In the case of boats, we cannot change the shape of a boat because they are huge and they display a big amount of water. Moreover, there is air inside them which makes the boat lighter, and as a result, boats float. Let's continue with our experiment about submarines.
Our hypothesis was incomplete, as we have explained before, now we know that. Submarines are affected by upthrust and wave forces too. They have a ballast tank that changes the weight of the submarine. When the ballast tank is full of air, the submarine is lighter and the upthrust force is bigger and it floats. When the ballast tank is full of water, the submarine is heavier and the weight force is bigger and it can sink. To make the submarine, we need a plastic bottle, a straw, 2 coins, and sellotape. We stick the 2 coins with sellotape and between them we make a hole. And we make another hole in the top of the bottle and we put inside a straw. This has been our experiment. Thank you very much for your attention. Now you can make us any question that you have.
Presentation. Well done for being the first ones, because it's difficult to be the first one. You must be very nervous. The English was fantastic. It looked very complicated, the experiment, and the data was very interesting. I really liked your presentation a lot. Have you ever seen a submarine in real life?
Yes.
Yeah? Really? Okay, fantastic.
I really like your experiment as well. I can see you worked really hard and you included a lot of different variables. So, about the experiment, now that you showed us, who can tell me then, how can a submarine, which is so heavy, actually float?
Because the submarine has a ballast tank which makes the water go inside them and she can float.
Sorry?
A ballast tank that makes the water go inside them and it floats.
It floats when the water goes inside?
Not the air.
When the air goes inside. Right, thank you.
Our school realized when we did of having a health program with all the things that we were doing. The Protagonizándolo program has 3 main ideas, which are sports, emotional education, and food and nutrition. We have observed on our playground that our students usually bring processed cakes and fruit and candy juices or meat that contain huge amounts of sugar. We know sugar is responsible for obesity, diabetes, and bad behavior. Everybody likes sugar. However, there are different types of sugar, so we wondered if we could make a dessert that was healthy and visually attractive at the same time and had only little amount of sugar. And in this way, practice without a doubt our best choice. We wanted to make something easy, healthy, and of course, funny. So, we like fruit because it's healthy, and we love jelly because it's funny and easy to make. On the top of this, not everybody knows that jelly is excellent for bones, joints, and skin as well. This means that we have a very good combination for a perfect dessert. Now, Sarah is going to explain the question and the hypothesis.
Thank you, Maria. Based on all this background, we decided to investigate if we could test the jelly solidification process. There are different types of sugar, added sugars, and naturally occurring sugars. Glucose is the most simple, the one that our cells need to work. Other types of sugar are transformed into glucose by our body. Our experiment is divided in 2 different parts. We had to wait until we finished the first part to formulate the hypothesis. Based on the glucose levels that we tested using urine test stripes, we made our hypothesis. We think that fruits with a high amount of glucose are not going to solidify.
We established all the control samples by using glucose tablets and urine test stripes by dissolving 2 tablets into 200 milliliters of water. We did solutions at 4, 2, 1, 0.5% by taking 100 milliliters of the previous mixture and mixing it with water. After our prediction, we wanted to check if we were right or not by using the stripes with the fruit. Once we knew all the glucose levels, we made our hypothesis. We dissolved neutral jelly into warm water according to the label instructions and put the pieces of fruit inside. We were not very convinced with the results, so we wanted to check it with another jelly, a commercial brand, with sugar. The results were the same again. Now Maria is going to talk about the data and conclusion. You can see here what Andrea was talking about. This chart shows that jelly with or without sugar solidifies the same. Solidifies, not solidifies. This one shows our predictions of glucose levels. The black part shows the real glucose levels, and the green ones are our predictions. It shows that we were quite wrong. Our hypothesis, as you have been able to observe based on the analysis of the data, was wrong. Glucose levels do not affect in the gel solidification process, neither with sugar nor without sugar. However, we cannot establish a direct relationship between the amount of sugar and the gel solidification. We wanted to learn the reason why this had happened, and we found out that tropical fruits have enzymes called proteases that act like scissors cutting the bonds of collagen in gel.
To finish, for the next investigation, we would like to investigate if there is any way to neutralize these enzymes in order to make a super healthy tropical dessert. And this was our investigation following the scientific method. We hope you enjoyed. We want to say thank you to our teachers, our school, to the Faculty of Education, to our partners, Maria and Ada, and to...
All of this is very healthy, interesting, funny, and super. But so what? Why have we studied sugar for? Because we want to make people aware of this. This is what we usually see as a snack in our playground. For example, the chocolate milkshake contains 27.6 grams of added sugar. And this is what we should be eating more. For example, the orange contains 10 grams of naturally occurring sugar. So, the secret is the bag. And this was our experience. We hope you enjoy.
Very interesting, it's very, very useful. I want to ask a question. Why is jelly good for you?
Because it's so funny, because of the movement.
Because it's funny?
Yes. Yes.
It's healthy because it's
Yes,
healthy because
it's
it's funny.
healthy, but also funny.
What I mean is, what does jelly contain that is healthy for your bones?
Contain fruits that are very healthy
and also contain collagen.
I have to say I also really love your experiment. I think you worked extremely hard, and hope that the conceptual level is very rich, very complex, and I think you must have learned a lot. And also the graphs, the visuals, and the whole display is pretty amazing. So congratulations. I was wondering if added sugar is so bad for our body. You know, as kids, what do you think we should do to reduce the amount of sugar you guys eat? You know, what would you tell parents to do so that you have less sugar? Yeah. Because we've learned so much about sugar and nutrition, I wonder, what recommendation would you give parents in terms of what to give our children for lunch, or for dessert, for tea, to take to school, something that is healthy and at the same time is good for you and something you like?
They can give us fruit because it's very healthy. And the World Health Association said that we cannot eat more than 7 grams of added sugar per day, and the sugar in fruits doesn't import much.
Bueno, continuamos con el Colegio Público Ramón Sainz de Baranda. Deciros que este colegio organiza sus propias ferias de ciencias internas y ya van por la segunda Baranda Science Fair y este es el ganador de su colegio.
Good morning. Hello, my name is John and it's an acceso. Jorge, Irene, and Michael. We are the class humanos. We are going to do an experiment with magnets.
Eventually, we have more toys with magnets, animal figures, class, fantasy, fishing, etc. And looking at these toys, we started to ask questions about magnets.
Do magnets attract all kinds of objects?
We took this experiment for
All the substances within magnets attract only an object.
to test our hypothesis. We took this experiment. We used various household objects, some keys, coins, clips, rods, and a magnet. And several objects of different materials at home. Some keys of different metals, and test if all of them get stuck to the magnet or not. This one is of iron, and it gets stuck to the magnet. But this is of styrofoam. This is of nickel, and they get stuck. Oh. This key is of iron. This is an aluminium key, and they don't stuck. It's plastic, and they don't stick. Only a few metal objects get stuck to the magnet, while other materials of wood, plastic, rocks, or metals don't. Magnetism. Magnetism is the property of magnets to attract other magnets or some metal objects.
Look at this. When a metallic object is in contact with a magnet, that object becomes a magnet, so we can imagine a circle.
like gold, silver, bronze, aluminum, etc. are not attracted by the magnet.
Now we are wondering, but how do we use magnets in our daily life? We use magnets in our daily life, in toys and hangnots on the refrigerator, but we don't know another uses for the magnets. We look for information and we found there are lots of uses for the magnets.
Example 1. Brakes. Materials. One clean neodymium magnet. A cover tube. A die. And a tube of length. This tube is a metal tube with an electrically conducting material. It doesn't have magnetic properties. Aluminium, copper, silver. In this case, we are going to use a rod of aluminium foil and a tube.
Let's see how I see that an aluminium magnet works on the cargo. Let's see how a plastic die works on the aluminium tube. Now we are going to do the same with the magnet. Magnetism is able to slow its movement down. The magnet for the metal tube generates electromagnetic current that slows its movement down. This phenomenon is used as well as voltage. Materials. A magnet, iron sheets, a put on a magnet. Mix aluminum and iron sheets in the container. Put a magnet on the lid and switch the lid. Iron feeling predominant at the lid. This is used as well as pasta plate. In this plastic has a very important. Materials. CDs, CD case, magnet, and hot glue. In what you encounter in the two CDs with the same color. Put the CDs on the CD case. The above one is repeated on the other.
When a magnet is broken, its obtained part becomes a magnet.
A curiosity we can make with magnets. We use transparent ball with water, magnets, and water stoppers. Stick each magnet to a water cup with the same ball and fill the ball of water with the bottle caps inside. Observe the caps create regular figures. Materials: a magnet, a star, a washer, and a roller. Play with magnets. We can make a washer. We have learned a lot of things from our magnets. And only attracts metal, nickel, iron, and cobalt. The Earth is a magnet and has magnetic field. We have magnets in our daily life and have and that magnet can do very much quality. And this was our experiment.
very much for your presentation. The display is very, very interesting, right? And you showed us all kinds of cool stuff that we can do with magnets. We can actually play with magnets, right? And we can do little experiments and find out about magnetism. So very interesting. Good job. Right. Now I have one question. I'm sure you've learned a lot about magnetism and you've learned a lot about magnets. So how would you apply that to your daily life? How would you, now from what you learned, how would you solve problems, daily problems in your daily life using magnets? Do you think it's something you can do using magnets that you couldn't do otherwise?
The compass is a guidance tool that uses a magnetic needle to mark the Earth's magnetic north.
Maybe you can make your own compass. I can do all sorts of cool stuff with math.
I also make a compass.
Or you made a compass.
We use a styrofoam ball and a magnet. This compass is stuck inside a magnet, and if you see the north point there. And we take a compass to check, and its point there. To the north.
Well done. I really liked the presentation and the way that you put the information on your background, and you had so many different little experiments to show us and curious examples. What's your favourite? What was your favourite experiment that you did in the classroom that you enjoyed the most?
How to stop a roller coaster.
You had a real roller coaster?
Well, more or less. We used a minion tool to do this experiment.
Gracias. Continuamos con el Colegio Catalino de Aragón, de Zaragoza, mientras...
Is playing with pressure and temperature. We are going to increase the pressure in the bottle to increase its temperature, and then we will see what happens. Well, we are going to pour a splash rubbing alcohol into the bottle. Cup the bottle, shake it so as the inside wall of the bottle become wet. Now we have to cup the bottle with the pan and pump air into the bottle, so the pressure and temperature increase. Now we have a high pressure system into the bottle, and what we're going to do is first let's it into the bottle, and we're going to make a cloud. If we cut the bottle and pump air away, we could check how high pressure system bring good weather, what we call anticyclone, and low pressure system bring bad weather, what we call borrasca. We hope that you like our experiment. Thanks.
see the what part makes but we were very impressed. It was a real high wow factor. Even though we can make your explanation is also very clear, so congratulations. Now, I didn't really get that part about your conclusion. So, how does this connect to high pressure and low pressure? Can you explain that?
If we captivate and pump air again when the cloud is full, yeah, high pressure with good weather, what we call anticicle, and when we bad weather, what we call monsoon. The liquid we use for we use the liquid for evaporate and do the cloud.
So it's very
Colegio Público Juan Tapia de Zaragoza. Welcome.
Good morning. We are the students from year 6 from the primary school for learning the languages. And let's go to start. Oh, sorry. No problems. How density affects the buoyancy of the objects, and how does density allow us to determine what an object is made up of?
Now the hypothesis. Before doing the experiment, we thought that an object would float or sink depending on its density and the density of the liquid this known as ink. We also thought that we could determine what material an object is made up of when density has been discovered.
Obviously, to do this project, we have used some resources. The materials are: to measure volume, we have used a test tube and a feeding bottle. The objects we have calculated its densities are lead, golf balls, an orange with peel, another without peel, and a lemon. The liquids are water, soap, and glycerin. To measure mass, we have used a balance. For safety, we have used goggles. And to help us calculating the densities, we have used a density table. To help us looking for information, we have used some books, as for example, step-by-step science and experiments, and the Scorner book of experiments. Also, we have helped by some videos of YouTube about steps.
So, how did we do it? First, the object is weighted once. Second, the volume is measured by water displacement in a test tube or feeding bottle. Next, we divide the mass by the volume to calculate its density. Then, the results are calculated in grams per milliliter and kilograms per liter.
The density of the yellow ball is 1.42 grams per milliliter.
And the density of the pink ball is 1.5 grams per milliliter. Finally, we look at density tables. As you can see, here we have the results in form of graph. The orange part is the density of water, that is equal to 1 gram per milliliter. The green part is the density of glycerin, that is equal to 0.92 grams per milliliter. And finally, the blue bar is the density of soap. That is equal to 0.66 grams per milliliter.
I'll continue showing this graph. This graph shows the mass, volume, and density of the different liquids and objects we have calculated. The mass is represented in blue. The volume is represented in red. And the density is represented in green. You cannot appreciate very well the densities because the ones we have calculated are very low. Here we have the results in a form of chart. As you can see, when we remove the lid from water and we put it in soap, its density decreases. When we change the golf balls from water to glycerin, their density increases. The orange with peel has less density than the orange without peel. Finally, this is the density chart that we have used to help us calculating the densities. It has very dense materials, mainly metals, such as gold, lead, brass, or copper, and less dense materials such as wood from oak, pine, poplar, and
Our last step was thinking the conclusions. Liquids which have more density than water affect the objects to have more buoyancy. Others have such heavy materials that they also sink.
the density allows us to determine what material an object is made up of. The pink ball has more material than the yellow ball. This is why things in some liquids are not explode.
Density is a type of measurement which is used in physical chemistry to calculate the amount of mass that contains a determinate volume. Density is a very intensive property, which doesn't depend on the quantity you have, because density is always going to be the same.
The density is also a specific property because it permits us to identify a substance. There are never two or more substances which have the same density.
But do you know what's the original density?
King Herod II ordered to build him a new crown made entirely of gold with a gold ingot.
Goldsmith, come here. Make me a new gold crown with a beautiful ingot.
At once, Your Majesty.
When his crown was finished, he thought the goldsmith had used a mixture of gold and silver.
Here is your crown, Your Majesty.
You have cheated me. This crown does not weigh enough to be made entirely of gold. You cannot fool me.
No, Your Majesty, I will never cheat you, I swear.
So he asked to the best mathematician in his kingdom to discover if the goldsmith had been dishonest.
Archimedes, come here. Look at this crown. I think the goldsmith has cheated me. He assures me this crown is 100% gold, but I don't believe him. I want you to discover the truth, but you cannot break my beautiful crown.
As you wish, Your Majesty.
Archimedes knew the weight of the crown, and he was certain that he had to discover its density. But, as it was an irregular shape, he didn't know how to calculate its volume. One day, when Archimedes was thinking about it, he noticed that when his body was introduced into water, the level of water increased.
Africa, I got it. I got it.
This is how Archimedes discovered how to calculate volume of irregular objects and then calculate its density. Also, Archimedes discovered that the goldsmith had indeed cheated the king using a mixture of gold and silver.
Your Majesty, the crown is not 100% gold.
Up with his head.
This is how density was discovered.
But how this information from the experiment is used in real life?
This discovery is still used with all types of objects, such as the LED. The LED is used to cover cables of telephones, TV, internet, and electricity, and also for visiting roads. The core is used for the construction of vehicles such as boats and airplanes. The recycling of this material is used to respect the environment and to avoid the consume of natural resources. And finally, rubber. Rubber is used to make a lot of things, such as wheels, tires, and waterproof.
Well, this is the end of our presentation. We hope you like it and that you have learned something. We will be glad to answer your questions.
Congratulations, that was a very impressive presentation. We can see that you use skills from science, maths, English, and drama. And history, of course. History. So congratulations. I wanted to ask you a question about lead and why you put lead on the papers. What's the connection? What's the reason why you put lead on the papers to go underground? Do you know the answer to that one? Just curious.
We think that if we use that materials in cables, as they are used to pass over there the electricity, the connection is better than if we use other material which doesn't connect very well the electricity, so its connection is way worse.
Thank you very much. Congratulations.
Continuamos con el Colegio Técnico Agustina de Aragón, de Zaragoza. Serán los penúltimos antes del descanso.
Hello, we are students from Agustina de Aragón School, and we are very happy and excited to be here to present our science project in this important place. We are the scientific Marcos, the scientific Patricia, the scientific Lucia, and the scientific Matia. To prepare this project, we were thinking of something different to make. And finally, we asked ourselves the following question. Can we measure the temperature with something different from a thermometer? We researched in the internet and we found that alcohol expands when we heat it, so we can make a kind of thermometer with a bottle and alcohol, and then measure the temperature with it. So our hypothesis is, can we measure the temperature with a bottle? We need the following materials that are very simple to find everywhere, that are
2 bottles, red and blue colorant, alcohol, ice water, tap water, 2 bowls, and hot water.
First, we have to fill the hot water in one bowl and cold water in the other. And then we put the same quantity of water and alcohol in the bottle.
going to put the blue colorant. Now we are going to put the blue colorant. Now we're going to put some alcohol. Now we put the tape in the bottle. Very hard, because if not, this experiment don't go. Then we put the bottles in the hot water. And we can see how the water goes up in the straw, but it needs some minutes. After that, we put the two bottles in the cold bowls, and we can see that water doesn't go up. We can see that the bottles in the hot water goes up the straw, and the cold water doesn't. You can see that here it goes. The conclusion is that air cold with hot water expands, and in the cold water goes up. So the conclusion is yes, we can measure the temperature with a bottle. This thermometer is very useful if you don't have at home a thermometer, and with this experiment you can know if water is cold or hot. Now we are going to change the bottles. This goes down and they are going up. So thank you for we hope you have enjoyed this project, and thank you for listening. We say thanks for our teachers, Susana and Silvia, for help us in this experiment. So, aplausos.
Thank you very much. I think your teacher will be very proud of your presentation. It's very easy to follow, right? You use everything. I'm sure you'll get very good grades in your English exams, right? I have one question. Now, it wasn't clear to me why exactly the water goes up inside the straw when we have hot water and not in the rest of the bottle. Can you please explain that?
Because the alcohol expands when we heat it, so that's because the water goes up to the straw when it's in hot water.
But it's also heated. The rest of the liquid is also heated, not just the inside of the straw.
Because the straw is the only way to go up, because this is open, but this isn't open. So the only way to make pressure is through the straw.
So what is different inside the straw and
That
inside the rest of the bottle?
that inside the straw can make pressure.
Pressure.
Yeah.
Okay. Pressure. Yes. Thank you very much.
We are going to explain and prepare experiment. First, we would like to thank all the students in 6th grade in our school for helping us in this project. The title of our project is Why Do Some Liquid Mix and Others Don't? We're going to explain how liquids interact, and the final project is going to be a homemade lava lamp. We choose this experiment because you can see that in real life some liquid mix and others don't. For example, this happens in a salad. You can see that the oil and the vinegar don't mix. This happens when you are cooking and you have some oil on your hands and you need soap to dissolve and get clean.
So, to answer this question, why do some liquids mix and others don't, we have applied the scientific method. As you know, this method is divided in different parts. The starting point of this investigation is this question. Then we state the different hypotheses for our investigation. Vinegar and water mix because they have similar properties, vinegar and oil mix because they have similar properties, water and oil mix because they have similar properties, vinegar and water don't mix because they have different properties, vinegar and oil don't mix because they have different properties, water and oil don't mix because they have different properties. To find out which hypotheses are correct and which ones aren't, we are going to mix the liquids. For this, we need the following materials: food coloring to make water stand out, vinegar, a spoon, some plastic cups, water, a PET glass container, sunflower oil, some bicarbonate of soda for a lamp, a torch, and a stand. Now we are going to conduct the experiment. 1. Mix water and oil in a plastic cup, stir and wet. Mix color vinegar and oil in a plastic cup, stir and wet. After mixing all these liquids, we have observed that oil doesn't mix with any liquid, but vinegar and water mix together. At this point, we researched on the internet the different properties of liquids and we come across the concept of density. We can define density as the concentration of molecules in a substance. To make it clear, we can say that it is the weight of a liquid. The same volume of a liquid might have a different weight in different liquids. The heavier is the denser it is. So water and vinegar are denser than oil because they weigh more as oil stays in the surface. Finally, we conclude that water and vinegar are heavier or denser than oil. Consequently, water and color vinegar remain at the bottom while oil rises to the surface.
Now we are going to apply this method to make a homemade lava lamp. We decided to do this experiment. We found research on the internet and we thought people in our school were going to like it. It is very visual, colorful and fun. There is nothing wrong with it, it's very interesting. Now we are going to show you how to make a homemade lava lamp. First, fill a quarter part of the glass with vinegar, about 200 milliliters.
Add some colored water. After, pour the water of sunflower oil. Now, add the yeast and bicarbonate soda to produce a reaction among liquids. Liquid don't put too much or the reaction will not work. After the reaction of how the liquids interact will become into one with the bicarbonate soda.
We are going to put more bicarbonate.
We have observed 3 minutes and we ask ourselves 3 questions. First, the reaction will last for about 4 minutes, depending on the amount of bicarbonate we use. However, we can add more or less bicarbonate. Liquid with the amount and this will vary in slow motion. Why is the amount of bicarbonate important? Second, we try the experiment with and without vinegar, but it didn't work without vinegar. We wonder why and we try to investigate the answer. Why doesn't the reaction work with just water? Third, we can use salt but not be that interesting. It doesn't work that well. Why doesn't it work with salt? The last part of our project is to explain our conclusion. The first question is, why is the amount of bicarbonate important? If we add too much bicarbonate, the mixture saturates and produces a foamy layer in the surface. The second question is, why doesn't the reaction work with just water? The reaction is produced when vinegar and bicarbonate mix. Vinegar has an acid component that is called the acetic acid. Vinegar is produced by the fermentation of some fruits like wine or fruits. The vinegar we use in this experiment contains the 6% of acetic acid. Then we can say that bicarbonate is a base, vinegar is an acid. Base plus acid trigger a reaction of carbon dioxide that produces bubbles. The third question is, why doesn't this experiment work with salt? It doesn't work with salt because salt dissolves in water and doesn't produce a reaction. These are the ways we use for research. Now, finally, thank you for your attention and you are free for ask us some questions.
Congratulations. It was a very, very clear experiment based on something relatively simple, but you turned it into something very, very creative. So it was a lovely experiment to watch. Have you made lava lamps in your house? Do you have a lava lamp in your bedroom? No. No? Why not? Because they smell of vinegar or?
Because vinegar is smelly.
Well done, congratulations, it was great.
procede con el descanso, ya hemos hablado al principio que la novedad de esta Feria de Ciencias en Aragón es la conexión que va a tener este año con el Programa Nacional Ciencia en Acción. Voy a pasar el micrófono a su directora Rosa María Ros, nos va a explicar un poquito más del programa.
Vamos a dar un premio a el trabajo que al jurado de Ciencia en Acción le parezca que pueda ser del tipo de actividades que se presentan a la Feria de Ciencia en Acción, y el premio va a consistir en una ayuda a realizar un viaje que es participar en la final de Ciencia en Acción de este año, que va a ser en Algeciras los días 7, 8 y 9 de octubre. Entonces, el premio que reciba esta mención pues va a tener esa posibilidad de asistir y de participar a un evento internacional, porque Ciencia en Acción es la fase nacional de Science on Stage, pero también es la fase internacional, porque nosotros estamos abiertos a todos los países de habla hispana y portuguesa. Entonces hay participantes de Sudamérica y de Portugal. Después de la sesión nacional, el año que viene habrá una sesión en Hungría, y también puede participar alguno de los participantes de este año en la edición de Algeciras, puede ser que luego vaya también a Hungría. Es decir, que realmente es lo mismo, pero proyectándose más hacia afuera. Pero de todas formas, a ver, nosotros tenemos, ahora estábamos hablando un poco entre los miembros del jurado, que va a ser difícil para nosotros seleccionar solamente un trabajo. Entonces, a todos los demás yo os diría, leeros las bases, luego vamos a repartir un folleto a cada grupo para ver si os animáis a participar. Porque por lo que he visto, en estos 7 trabajos que hay, pues por lo menos a mí hay más de uno que me gusta y me gusta mucho. Entonces va a ser muy difícil, muy reñido esto de seleccionar solo uno, pero yo os invitaría a todos los demás a leeros las bases. Básicamente lo que hay que hacer es presentar un resumen que debe estar en castellano y en inglés. Son 20 líneas, no es mucho trabajo, y hacer un vídeo que se vea pues, lo que estáis haciendo. Entonces, con esto pasa a lo que es la selección online, y luego en el mes de junio vais a recibir una carta que os van a decir si habéis sido seleccionados o no para la final de Algeciras. Pero es que a Algeciras van a ir del orden de unos 140 a 150 trabajos, es decir, que realmente hay muchas posibilidades de ir. ¿Qué es lo que tiene de divertido Algeciras? Pues que habrá allí 150 tan locos como vosotros. 150 trabajos, multiplica por 4, 5. Hay veces, hay colegios, 4 colegios, es decir, hasta 70 alumnos han ido a una de las finales por trabajo. Entonces, realmente el ambiente es impresionante. Aquí sois muy ordenados, muy buena gente, están todos calladitos. En Ciencia en Acción hay siempre un barullo y ahí es dificilísimo entenderse. Pero bueno, es un barullo de emoción, de disfrutar, de pasárselo bien, de descubrir que la ciencia puede ser realmente muy interesante, muy creativa, muy divertida, muy...
una bomba de gas en una bomba de material. Nuestra bomba se puede escribir en la y si se descubría, Sergio, Bonjour à tout le monde. Pour commencer, l'explication, nous avons choisi le thème de la nutrition parce que le fédération avait l'odeur de la santé. Et le thermomètre de précision, la balance de précision, le matras, le briquet, les annotations, et après les aliments qui sont les fruits secs, sont la noix de macadamie, qui est ça, l'amande, qui est ça, les cacahuètes, ça, et la noix de cachou, qui est la macaron. Les aliments faits à partir de céréales, qui sont le macaroni, la madeleine maison.
Nous observons qu'est-ce qui passe et nous prenons des photos et des notes.
Resulta le ballon rouge reste dessus de le ballon bleu.
Le ballon bleu reste dessous de le ballon rouge, c'est-à-dire que les hommes noirs restent plus que les autres soirs. On va quelle heure est notre corps. Futur recherche possible.
Pendant que nous faisons cette expérience, nous allons aimer savoir la température à partir de laquelle les ballons se séparent.
C'est pour ça que la prochaine fois, nous aimerions faire ce projet en utilisant un thermomètre. Merci à tous pour attendre et merci aussi à les professeurs de français et à nos copains de notre relève.
Merci beaucoup et félicitations. Vous avez fait un très très bon travail. Et vous avez travaillé pendant longtemps, et je voulais juste vous demander, pendant ce temps que vous avez travaillé, qu'est-ce qui était le plus intéressant, ce que vous avez aimé le plus de faire ce travail ici, ce projet.
L'expérience.
Et le plus difficile, c'était le
Faire du travail.
Très bien, merci.
En tout cas, moi, je remarque que vous avez fait une expérience très simple et très claire que chacun peut reproduire. Et ça, c'est un point qui est vraiment intéressant dans le thème que vous avez choisi et la façon dont vous avez conduit l'expérience. Voilà. Merci. Bravo.
Muy bien, desde Jaca viajamos hasta Teruel, en la siguiente parte de la sala.
Good morning, ladies and gentlemen. Welcome to this presentation which will talk about scientific project.
Yes, a project.
One day, we were in class studying energy, and our teacher was talking about energy and mobile phones.
Yes, I remember that. It was fun.
Don't interrupt me. There is a lot of people here listening.
Sorry.
To stop the teacher talking, we began to think and to do questions. Questions like, how does the phone transmit the energy? And the most simple one was, how it functions.
Yes, and then another student
began to talk about his brother and how he dropped the man into the toilet.
Yes, he said he could draw using playwrights. Do you believe it?
I remember that, but to be honest, no, I don't believe it. I remember that first time when we have to use Adobe to research.
And this is why we thought we would be nice to make science about mobile. We asked to our teachers and they say yes.
And we begin to learn a lot about phones. I have found some data about phones. In December 2014, there were more than 50 million mobile lines in Spain, more than one per person. Apple sold 340,000 iPhones per day in 2012. Mobile phones have 18 times more bacteria than toilet habits. In Japan, 90% of mobile phones are what for because youngers use them every in the shower. Thousands people in the world have mobile phones than toilets. Scientists have developed a way to change mobile phones using lugar.
Wait a second. Do you mean pig?
Yes. Yeah, P. It's crazy. We asked our teachers to try to change using P, but he said no.
But instead, they told us to do some research about such as ideas, like the rice meal and emergency batteries. And we accept the challenge to come in here to tell you about our crazy experiments.
Otherwise, the first thing we do is to find ideas in YouTube. We look for experiments related to phones, and we found lots of those. But it was difficult to know if it was true or not.
Wait, the scientific method?
Yeah, do you remember it? The boring stuff the teacher told us in class?
No.
What? We are in the science fair and you don't know what the scientific method is?
Don't worry, we can always use the phone to contact our team in the laboratory and they will tell us about it.
Hello, Esther.
There's the lights.
Hello, Esther. We have a memory problem. Could you explain us why the scientific method is?
Yeah.
Okay, our question for this experiment is what? It is true that if a mobile phone falls in water, you can dry it using plain rice?
What about the other question?
What question?
Yes, the other question was, can we charge a mobile's battery using home items in case there is a power outage? Or a blackout? Go to a storm?
Yes, now I remember.
So to the point, we prepared both experiments, so we had to discuss if the rice worked or not,
and how to use up the phone.
But we couldn't destroy a phone, would we?
One of our teachers casually dropped a phone into the lake. So we started investigating about how we would dry up the phone. And we came across another option, to use another way to dry light. For example, silica gel. Yeah, the tiny boxes in the shoe box.
With the lemon, some copper cones. We made an attempt to make a battery follow instructions in the science book and YouTube videos.
But it didn't work, so we had to research more, and we discovered that it could work better replacing the clips with nails.
And we repaired, and the battery experiment worked. But we only can light a LED light. The phone did not charge at all.
So we decided to change a bit, and then we tried it using aluminum. Copper wire, we replaced the lemon for salty water.
Yeah, it works. Yes. But what about the rice and the gel? Let's tell these people.
Wow, it turned out to be super effective. The gel breathed up the water way faster than we expected.
Yeah, what boring experiment.
But it was easy to do, and it functioned.
Those are our experiments and our conclusions. We hope you like them.
Okay, congratulations. Very interesting experiment. I wanted to ask you a question about charging a mobile phone. You use lemons.
Yes.
Is it possible to charge or to create energy with a different kind of fruit other than lemons?
We can charge with other type of fruit, but with lemons charge more and produce more energy because of the juice of the lemon.
Yeah.
That's right. Thank you. Good job.
Thanks very much. Congratulations.
Thank you.
Present our experiment. Our names are Sonia, Cynthia, Emma, and Javier.
The name of our experiment, like you can see, is conductive force. That you can imagine is about electricity.
But what products that we can find at home are more conductive, acid or solid liquid?
We think that vinegar is the most active liquid. This is what is going to conduct more.
And what material do we use?
We use coffee, coal, vinegar, water, lemon juice, orange juice, and also salt.
How do we get it?
First, we have to connect the pieces of copper to the crocodile clip pins. Then we have to put the pieces of copper into the liquid. After that, we have to switch on the voltmeter to see how much it conducts. Finally, we write some results of some liquids that we dry.
We try with orange juice that the result is 1.3, with vinegar the result is 3.3, coal is 2.6, water 1.66, coffee 1.3, and lemon juice 2.6. going to teach. Now we are going to explain the data.
As you see, this is the water, this is the banana, the coffee, the lemon juice, the orange juice, the coffee, the coke. As you see, the vinegar is the most conductive liquid, and water and coffee the less ones. But when we try with water with salt, we see that water with salt conducts more.
And the winner is water with salt.
Oh, so the conclusion is that acid conduct but doesn't conduct a lot, and salty products conduct more. Yes. We hope that you enjoyed with our experiment.
Thank you very much. Thank you. I think it was a very clear presentation. We were impressed by all the application of methods and materials that you've used, and that we could follow it very easily. Now, I didn't hear anything about applications. So, what applications would you draw from what you've learned here? In terms of electricity and conductivity, is there something that you would need to remember, or any application that you can think of?
For an experiment, it's nothing that you need in your daily life.
Okay, so if there was electricity, there was a cable of electricity, and you wanted not to get electrocuted, then what?
You can use, but this normally that you use different things like lemons or other things.
All right, thank you very much.
The internet. But after searching and searching, we realized that our idea was already invented. And this is the camera obscura. First, the Greeks already had some ideas of what this phenomenon was, but their cameras obscuras were much bigger than the ones we have got here. See, they couldn't even get inside. But it wasn't until the year 659 that Al-Hasan, an Arabic philosopher, gave the cameras obscuras a true explanation. He proved that the ideas of the Greeks that the eyes had rays to point to see everywhere were totally wrong, and that it was the light who entered the eye so we could see. When Al-Hasan discovered this, the cameras obscuras went very popular. Painters, for example, used it to see better the landscapes. As you can see here, they made a mirror and they put it here so the light reflected, and they could see it right here, so it was easier for them to copy. Finally, some years later, Giambattista della Porta, an Italian inventor, improved this even better by changing the hole by an old man's lens. Now, Andrea is going to show you what do we need to make such a project like this.
As we are very kind kids, we are going to show you how to do it. But first, you cannot make any project without the materials. The materials of this project are a shoebox. Look that it don't have any hole and it's not a little one. A black paint. If you don't have oil paint, you can use other things. It will probably work the same. A newspaper and a metal one. In Mary's proof paper, you can see the images. And a ruler to cut the outside parts of the camera scura, a ruler to cut the straight line, and a pinhole. Now Nuria is going to talk about the process.
Now you have learned everything you need to make our camera scura. Let's get started. First, you have to cut each single part of the camera scura with the cutter. It's important to leave 2 centimeters of space between the hole and the edge of the box. Then you have to paint each single part of the camera scura with black, because it makes dark the camera. But the paint has to dry, so meanwhile, if you want to decorate it, you can spend all the time the paint is drying to decorate the cover of the box. When the paint is dry, it's time to stick the metal paper and the grease paper. It doesn't matter in what hole you have to put it, but it's important to stick in the inside part of the box and not in the outside. Finally, when you think everything is okay, it's time to do a hole with a pinhole in the metal paper. I'm sure that if you do a separate like this, you will like to prove it. So, when showing everybody our project well done, you have to point with the metal paper the powerful light or the sun. And you are not going to blind because you will see to the grease paper the light that you are pointing. If it doesn't function well, don't worry because we didn't do our project in only 1 day. And now, Guillermo is going to talk about the garden.
I still remember when David entered to our class and said, "Children, I decided who will make the project." He said that it's from our class, and all the people started shouting, and then he said, very, very slowly our names. We started making the project in February, and we finished 1 week before the science fair of Zaragoza. One day in a meeting, Gonzalo and Nacho, experts in cameras, came and explained how to make a simple camera scura like this. We done all one. All have only mistakes. Nuria used a thicker paper. Andrea did the hole in the grease-proof paper. Jorge didn't paint the inside part of black, and I did the hole so big. Then we did other camera scuras and functioned perfectly well. And then the biggest one, camera scura. If you want, we can show how it works. Look. As Guillermo has said, take the camera. Yeah. How look it from please? Look, can you see? Wait a second. This is upside down.
Yeah, it's different. It's upside down.
Thank you for staying and hear us.
No questions. Very good. It was very clear indeed. Thank you.
I'm the wooden spoon. I'm the plastic spoon. Now, we are going to explain you our experiment. We are going to start talking about how the production of the heat used to metal, wood, and plastic. First of all, we have put some boiling water in the glasses. Then, we add some water to the metal spoon, wooden spoon, and plastic spoon, and we attach a clip to each one, like this. Finally, we put each spoon in a glass with boiling or very hot water. Now, let's see what it happens. I'm the metal spoon. When I jump into the hot water, I get hot, what means that my temperature increases.
Little by little, I transfer the heat to the butter, which suffers a physical change in its state called melting, changing from a hard state to a soft state. When the butter melts, the clip falls. As a result, I can affirm that I am a good conductor of the heat.
I'm the wooden spoon. When I add to the hot water, I get hot, but not as much as the metal one does. However, I'm the only material that absorbs water. Because of the heat I got, the butter becomes a bit soft, but not as the butter in the metal spoon. So the clip takes longer to fall down. Therefore, I can say that I am a bad conductor of the heat.
I'm the plastic spoon. When I jump into the hot water, I don't get hot, so my temperature doesn't change. As a result, I don't transfer heat to the water, and the clip doesn't fall. Therefore, I can affirm that I am an insulator material of the heat.
Now, we are going to repeat the experiment, but this time the spoons are going to be inside a glass with room temperature water. Are you ready to jump into the water?
Yes. Yes, we are. Now I'm into the room temperature water. As my body temperature is the same as the water, I don't transfer heat to the water, so the clip doesn't fall.
The same is happening to me. I'm into the room temperature water, but my body temperature is the same as the water, so I don't transmit heat to the water, and the clip doesn't fall neither.
That's what happened to me too. However, for me it is normal. As I am an insulator material, I don't get hot or cold, and I don't transmit heat or cold to any other object. I have always the same temperature.
So, why are we not transferring heat to the water if we are heat conductors?
In this case, you don't transmit heat to the water because your body temperature is the same as the water temperature. So you don't get hot like it happened when you were in the hot water. Do you understand me now?
Yes, we do. Now, I'm very cold. I can't stand it.
Now, we are going to repeat the experiment, but this time the spoons are going to be inside a glass with cold water. Are you ready to jump into the water for the last time?
Yes, we are. I'm very cold. I can't stand it. When I jump into the cold water, I get cold, what means that my temperature decreases. Little by little, I transfer the cold to the water, which suffers a physical change in its state, becoming even harder than when it's at room temperature. Therefore, the clip doesn't fall. As a result, I can affirm that I am a good conductor of the cold as well as of the heat.
Are you okay? Now that I am into the cold water too, I feel a bit cold, but I can't stand it. I get a bit cold, but not as the metal spoon, so I transmit a little bit of cold to the water, which becomes a bit soft than before. Therefore, I can say that I am a bad conductor of the cold.
Ricky, are you cold? I can't feel anything. When I jump into the cold water, I don't get cold. It means that my temperature doesn't change. Therefore, I don't conduct cold to the water, and it doesn't become harder than before. Even so, the clip doesn't fall because it can't slip out of the hard water. Because of that, I can affirm that I am an insulator material of the cold.
To finish, I need to check that I have understood how do you react to the different temperatures. Metal spoon, can you transmit heat and cold to an object that is in contact with you?
Yes, I can. When I'm hot, I transfer heat to other objects.
And when I call, I transfer call to other objects. So I can confirm that I'm a good conductor.
Yes, I.
And what about you, Mother Spoon? Can you transfer hit and call to an object that you touch?
Yes, I can, but I don't do it properly. The metal spoon is better than me at doing that. As a result, I can say that I am a very bad conductor, almost an insulator.
And what about you, Plastic Spoon? Can you transfer hit and call to an object that is in contact with you?
No, I can't. I don't transfer neither the heat nor the call to the object that I touch. So, I can affirm that I am a good insulator.
Oh, now I understand. Metal is a good conductor. Wood is a bad conductor and plastic is an insulator.
Thank you for your attention. We hope you have enjoyed.
Entonces, en cada stand, en cada mesa, pondremos la evaluación correspondiente con la puntuación total. Habrá un ejemplar en cada mesa que no se puede llevar, porque solo hay uno, pero se pueden hacer fotos, tanto de vuestro stand como de otros stands, para ver la valoración que se ha dado en cada proyecto por cada categoría. Es una manera también de poder trabajar luego en el aula, qué aspectos hay para mejorar, cuáles son nuestras fortalezas y nuestras debilidades. Comenzamos pues con francés, pero yo no tengo el veredicto. Ah. Venga, Steve. Comenzamos con el segundo premio de la categoría de modalidad de francés. Entregará el premio la directora del Servicio Provincial de Huesca. Y el segundo premio es para el Colegio Monte Oroel de Jaca. ¿Vais pasando por aquí? Como es la directora provincial para haceros una foto. Enhorabuena, chicos. Y para los profes. Entonces, el primer premio en la modalidad de lengua francesa para el colegio Marie Curie de Zaragoza. Entrega el premio Monsieur Patrick. ciencia hace entrega de su diploma con un espectáculo científico en vuestro cole y un viaje al planetario de Huesca para toda la clase. En el mes de mayo. Los premiados que no se vayan muy lejos, que luego haremos foto de familia, ¿vale? Podéis pasar. Y la directora provincial de Zaragoza.
Claro, igual les han ayudado mucho eso.
Bueno, como el jurado de la modalidad de lengua inglesa todavía no ha aparecido, continuamos con el jurado de Ciencia en Acción. Su directora, Rosa María Ros, va a hacer entrega de un pase directo a la fase nacional en Algeciras en octubre del 2016.
En primer lugar, quisiera deciros que para el jurado de Ciencia en Acción ha sido difícil, muy difícil decidir solamente un trabajo.
En Aragón. Vamos con el segundo premio. A la entrega el director provincial de Teruel, el Instituto de Nanociencia, con un espectáculo científico y un viaje. No, perdón, eso es el primer premio. Segundo premio, el director provincial de Teruel.
Es Julián Nieto.
El Departamento de Educación del Gobierno de Aragón está entregando unas mochilas con uno de los monstruos de la innovación. Y el momento más esperado, el ganador de esta feria de ciencias en Aragón, modalidad lengua inglesa, hará entrega del premio la directora provincial de Zaragoza. El Instituto de Nanociencia entregará el primer premio, que es un espectáculo viaje para toda la clase al planetario de Huesca y recordamos que todos los participantes tendrán recuerdo de la editorial Santillana, editorial Bailey, Netedu y las mochilas de los monstruos de la innovación del Departamento de Educación. Y el primer premio es el Colegio José Antonio Labordeta de Zaragoza. Por tercer año consecutivo ganan el primer premio enhorabuena, chicas. A sus profesoras. El jurado de inglés es imparcial, es decir, es imparcial. Un regalito más de la editorial Bailey. Vuelve a subir por favor el Colegio Julián Nieto Tapia, segundo premio, nos queda el regalo de Bailey y vamos a ir llamando a todos los centros, por favor quedaros allí y se irán sumando el resto de participantes. Vamos a empezar con los premiados: Colegio Monteoroel, Colegio Mami Fugui y Colegio San de Baranda, por favor. Suben todos los premiados. Llamamos ahora al Colegio Las Anejas de Teruel. A su profesora Andrea Solano. Llamamos al Colegio Cervantes de Acea de los Caballeros. Colegio Miguel Artazos de Utego, Zaragoza. Y sus profesores acompañantes, Víctor. Colegio Agustina de Aragón de Zaragoza.